Hi guys, good morning. Happy New Year to all of you. It's been so long since you met. How was New Year, people? What did you do on a New Year? Huh? Anything special? Nothing special. Ah, Rohan says nothing special. What about others? Did you go out? Go out and eat? Hmm? Okay, Abhishek also says nothing. So this year it was happening only to me. I was in Kerala. I was traveling. I went to Trivandrum. I went to what is this place? Alapi, and I went to Varkala, right? So it was a very nice trip. New Year, and this year entirely I didn't go anywhere. So this was the first trip. It was very nice. Anyways, so shall we start, people? Are you ready? Okay, let me share my screen. Yeah, so we have completed your chapter, equilibrium, right? And it's actually good that last week you didn't write the test because it's a little big chapter. You have to study a bit for answering questions, right? So maybe definitely this week it will happen, your equilibrium test. Okay. I have completed everything, and I heard that I didn't complete certain this thing in equilibrium. Is there anything I didn't complete, guys?
Topics, sir.
What was the topics?
1 minute, sir. So this is some topic called solubility equilibria of sparingly soluble salts.
We saw, right, salt hydrolysis, pH of acidic salts, basic salts. That only is salt hydrolysis, pH of salt hydrolysis.
It comes under this, sir.
Yeah, we did know pH of an acidic salt is equal to 7 minus half into pKa plus log C, that formula.
And
Do you
there's
remember?
a common ion effect on
Okay.
solubility effect.
Yes. Common ion effect. I forgot. That's a very simple thing. The common ion effect. If you can understand what is Le-Chatelier's principle, right? I hope you remember Le-Chatelier's principle. Ways to disturb the equilibrium, right? So if you can understand that common ion effect is very easy. Say for example, like okay, we are seeing common ion effect. Okay. So what happens? Say for example, what I'm telling is, for example, say I have HCl with me. Okay, I know this is an acid, right? So this will give me H plus Cl minus. This will dissociate to give me H plus and Cl minus. Right. Now this solution contains only HCl. Right. So obviously there is no restriction for this reaction to happen. So more and more dissociation will happen. Right. But what if I have a solution? Right. I have a solution. Right. Right, in which there are two things. One thing is HCl. One thing is HCl. Say other thing also I have in the same solution to be NaCl. Okay, right. Now NaCl also will give me Na plus and Cl minus. Right, HCl will give me H plus and Cl minus. Right, so I can write that reaction also. Say NaCl is a strong electrolyte. Right, will give me Na plus Cl minus. Okay, now what do you see here is that both these HCl and NaCl gives me what is that, Cl minus ion. Right, so this is the common ion between these two solutions. Is it not? Cl minus is the common ion between these two solutions. So because of the presence of NaCl, what do you think is going to happen to this reaction? Tell me. Right? Because of the presence of NaCl, this reaction dissociating, what will happen to this reaction? Can you tell me? Any guesses? You might not end up with the correct answer, but any guesses what will happen? Hmm? Okay, so what you see here is that both these reactions Cl minus is common, right? In the sense that both these reactions give Cl minus, right? So because of increase in concentration of Cl minus, what is happening? Can I say the Cl minus total Cl minus concentration, right? Total Cl minus concentration comes from this as well as this, right? So what I'm trying to say is that you are indirectly increasing the concentration of Cl minus, is it not? Because of the presence of NaCl in the solution of HCl, right? You are increasing the concentration of Cl minus, right? So what is going to happen? Or can I say in this particular case, you're saying that I am increasing the concentration of products. These are Cl minus is the product here, right? So tell me what will happen in an equilibrium if I have increase in concentration of products? Le Chatelier's principle. If I have increase in concentration of products, which side the reaction will move? Hmm? Tell me, if I increase the concentration of products, which side, backward or forward?
Forward, sir.
No. See, what does Le Chatelier's principle says? If there is an effect which causes change in equilibrium, this is the cause. This is the increase in product is the cause, which is change in the equilibrium. What will equilibrium do? It will go to a direction where this effect is minimized. That means you are increasing the concentration. The equilibrium will go to a side where I have where it will decrease the concentration of the products. Which side it is? Which side, if I go, I can decrease the concentration of products? Which side? If I go forward, what will happen to the concentration of products? Concentration of products will keep on increasing. So obviously I have to move backward direction so that the concentration of Cl minus decreases, or in general, the concentration of products will decrease if I go in the backward direction. Right? So indirectly, what I'm trying to tell you is that, guys, if I don't have NaCl in this, if I don't have NaCl in the solution, right, this will give me more amount of dissociation. The HCl will give more and more dissociation to give me H plus and Cl minus, right? But since I have NaCl also, which has the common ion of Cl minus, right? Now, this particular reaction is not going to happen much, in the sense that, say, before NaCl was present, it was 90% dissociation. If NaCl was put, it would be around only 50% dissociation, right? Hope you're trying to get the point. Why is it happening? Because you have a common ion, right? So if common ion means you're in the product also, you're also in the product. Basically, you're increasing the concentration of product, right? So obviously the reaction will move more and more in the backward direction, indicating what? This dissociation will not happen, but more and more amount of HCl together will be formed. Okay, so this is what is called as common ion effect. This will help. This particular thing, whatever you say, you can apply it in various situations also. Okay, everybody understood, guys? Is it understood? What do you mean by common ion effect?
So HCl concentration will increase, sir.
Yeah, concentration of no, you cannot. It's not like that. But what I'm trying to tell you is this reaction will not happen as much as efficiently as before. That is, the HCl dissociation reaction will not happen as efficiently as before. I think the presence of NaCl, this will not be much dissociated. But if the absence of NaCl, yes, this will be perfectly dissociated. That's what I'm trying to tell.
Okay, sir, understood.
Right. So this is what is this is what is common ion effect. Okay. Right. So you can read through your book. If you have any doubts, you can ask me later also. right? They would have given different example, but I took different example, but eventually the concept is same. Okay, fine. Now with this, equilibrium is over. Done. Okay, so we have next upcoming two chapters are pretty big, and hope you know that for the next 2 weeks, right, you have daily class for chemistry 7 to 8. Okay, and it's going to be interesting, guys. I am not going to bore you. That the part which you're going to see is my interesting part. Like, I mean, for me, that organic is the most interesting one compared to physical and inorganic. So I will also make sure that you love organic. Okay, but since you are in just the level of CBSE, maybe I will not be able to scale up that much. But still, wherever, if I feel that you might want to know it, I will give you the details. So many details. See, it's very vast. Okay, organic chemistry is a subject. You might say it's a part of chemistry, but no, organic chemistry itself is a very huge subject, right? So whatever you are going to see is just the basics, right? So even at the level of for me doing PhD, still I study organic chemistry, still I study reactions, still I study mechanisms. So many, it's just vast. There are so many areas, different areas itself in organic. Okay. So, anyways, so like you hope you know where and all we use organic chemistry, right? So obviously in the form of drugs, all you see coronavirus, vaccines, right? All these things are actually all, not only that, any drug you take, paracetamol, aspirin tablets, any painkillers, all these things, whatever you take are actually organic materials. Okay, first of all, what do you mean by organic materials? Generally, they are carbon containing compounds. That's how I generally say it. But by the term organic, you should not, generally, when I say organic farming, right, or when I say an organic shop, what do I say? Generally, that means it is naturally, like the product is available naturally. It's not chemically synthesized. But that definition will not work here, right? Because so many of the organic compounds are chemically synthesized. It's not like it's completely natural. But how do I properly define organic compounds? Is anything which is a compound of carbon, right? Anything which contains carbon in it, right, is generally called as what is that? Organic compounds, right? So in so many dyes, you use your clothing, different color dyes you're using, right? And all your enzyme mechanisms inside your body, there are going to be enzymes, right? All these are going to be actually organic compounds. Even your cell, right? Even every cell in your body is actually made up of some kind of organic compound, right? The list goes on, right? I can just speak about where and all organic compounds are present, because we know, right, carbon is the essence of life, right? Our entire body, our entire universe is made up of carbon compounds. Okay, so you really cannot say not connect yourself with organic compounds, even if you don't know that these are organic compounds, but actually you make sure that you are actually dealing with them in day-to-day basis. Okay, right? So I'm going to give you a very brief, very good basic for you to move on to the next levels. Maybe say when you go to 12th, if you're going to take JEE Mains or JEE Advanced, whatever I'm going to teach you is really going to be helpful. And somewhere I will be touching a little of higher concepts also, right? Okay, and guys, and let me tell you this: it's physical and inorganic comparatively, I would say, are a little easier to students, right? Why? Because physical chemistry, you just have to study the formulas, problems will be asked, you know the formulas, you apply it and get the answer. In organic chemistry, there's not much in this thing. You just have to understand the concept, maybe sometimes mug it up, right? And then you write the answer. But organic, right, you really have to practice a lot. There are a lot of reactions, a lot of small things which you have to take care, right? And that comes only with practice, right? If you're gonna just listen to the class, maybe you will understand, definitely will understand, there is no doubt about it. But after 2 days, if you're gonna take a notebook and start solving anything or start answering any question, maybe you'll find it so difficult. Okay, now it's a good advantage that your school has already completed the chapter, right? I have some little over advantage there, so I can little more give you more. I can give you more clarity on what we have learned. Is that cool? Right? So any doubt anywhere, please feel free. Like, I know, most of you does not ask doubts. I don't know whether you understand or not, but I would really appreciate if you can still stop me right there whenever you have doubt and ask me. Right? I'll be very glad to explain you again. Okay, so we'll start. So the chapter name, isn't it? It's I generally call it general organic chemistry, right? So I think it's some general principles and isolations of some organic compound. That's what it is, right? So anyways, that's the chapter. Okay, guys, fine. So let me start with this. Okay, now you know that in obviously you're going to study about organic reactions, right? It's not like normal, like how you have normal chemicals, NaCl, KCl, KMnO4, all these things. You actually do not talk about something called as mechanism of a reaction, right? What do you mean by a mechanism? So what do you see when I say reactants are giving products, right? This is a reaction, right? But how these reactants are getting converted to products, what are inside things happening, which is attacking where, right? All these we don't care, we are not concerned much in case of inorganic chemistry, inorganic reactions. But in organic reactions, right, very the smallest of things, any reactant getting converted to product, we are interested in what is happening inside the reaction. We are not concerned only about the overall reaction, right? We are actually concerned about what is the inside thing happening, how exactly only this product is formed, right? A lot of questions can be asked, right? Fine. So in general, how an organic reaction occurs is the question now, right? So I can give you a flow chart. I'm going to give you a flow chart which depicts in general how an organic reaction occurs. Okay, fine. So I am going to have something called as substrates. Okay, I'm going to have something called as substrates. Now you know there are going to be different you must have learned in 10th also, now you would have learned in 11th also. There are something called as functional groups, isn't it? Alcohols, alkenes, alkanes, alkynes, aldehydes, ketones, carboxylic acids, esters, this, that, so many are there, right? So this and anything can be a substrate. Any I would say these are the reactants. Okay, when I say substrate, they are the reactants. Okay, now these substrates, right, these substrates will be attacked by something called as reagents. Okay, these substrates will be attacked by something called as reagents. For example, let me tell you, I have a C double bond C, I have an alkene, right? Say now I had H2 to this, what will happen? I know I'm going to form one H to this one carbon and another H to this carbon. So that's what is happening. So in this case, you see this is the substrate and this H2 is the reagent. Hope you understand. Whatever you put inside the on the arrow mark are generally what are called as substrates. Sorry, reagents. Okay, and this is the substrate. Whatever is actually undergoing the reaction, that is the substrate. Okay, fine, done. So you understood the difference between what is a substrate and what is a reagent. Okay, so substrates are there and reagents are going to come and attack the substrate. Okay, fine. Let me wrap this part, guys, because I have to give you the flow chart. Okay, so now they both will react together, right? So obviously before the reaction ends, so before the reaction ends, I will have some intermediate formed. So I told you we are interested in what is happening inside. This is exactly what is happening inside, right? So we will study about each and every one of them. Don't worry, guys. Okay, so reagents will attack the substrates and they will form something called, they will react together to form something called as intermediates, and these intermediates are unstable, people. They will not be able to stay there for longer time. They are not the end products, right? Now they will eventually gain something, like they will say, for example, accept H plus or lose H plus or lose electron or accept electron. Something will happen, right? They will accept something or gain something to form the final products. Okay, this is the overall flow chart of any organic reaction for that matter. I have substrates. These substrates will be attacked by something called as reagents, and they will react together to form an intermediate which is unstable, right? And it will not be able to stay there for a longer time, so it will accept something or gain something to form the final products, right? So this entire thing is what is called as, in general, mechanism of an organic reaction, right? This entire thing is what is called as mechanism of an organic in general. Okay, right. Now we are going to study about everything, right? All four objects. But yeah, substrates and products. Again, it'll substrates will study about them. How do you name them? What are the isomers? Different this thing. And intermediates, I have three main types of intermediates you can see in organic chemistry, right? Again, reagents can be of two types, right? So everything we'll see. Everything properly we'll see. Okay, but for now we'll concentrate on the substrates. Okay. Guys, do you have IUPAC naming also? Did they teach you IUPAC naming in school when
Yes,
when they
sir.
taught this chapter?
We
Okay,
have that.
wonderful, wonderful, cool. So we'll start with that only, right? We'll see different types of substrates, right? And how do you name them? That we'll see first. And second thing we'll see would be the isomerism, right? We know what is isomerism, like same molecular formula, different structure, all these things. So that again we'll see. Okay, fine. So this is the overall thing I wanted to say. So we'll move on. We'll move on to IUPAC naming. Okay, so we know what is IUPAC, International Union of Pure and Applied Chemistry, right? So since we have, I don't know, some billions and billions of organic compounds, right? There is a system. There should be a systematic way of naming them, right? And the systematics. When I say systematic, that means there should be some rules governing on how to name a compound, right? So that rules are given by IUPAC. Okay, right. Fine. You must have known few of the rules, right? But before that, I don't want to go by the rules because you already know what you're going to do, right? Tell me, guys, what are the three main rules? What is the first rule? Tell me. What is the first rule?
Identifying the longest chain carbon.
Exactly. You have to identify the longest possible chain. Second thing would be to number the carbon atoms in the longest possible chain. But again, you have to make sure that, okay, fine. We'll see point by point. Okay. So the first rule is, or before seeing this, guys, right? So any IUPAC name, right? Any IUPAC name I can write a very kind of a small formula for you to remember, right? So it is any IUPAC name is equal to prefix okay, prefix plus root word plus suffix. As simple as that, right? So root word, okay, this prefix comes before root word, suffix comes after root word, right? So the entire IUPAC name of any compound will be a combination of these three: prefix, root word, and suffix. Okay, right? So again, as a prefix, a suffix can be again of two types, right? Right. So suffix can be of two types. One is what is called as primary suffix, and the second one is what is called as secondary suffix. Okay. Prefix, I don't have primary and secondary, only suffix has primary and secondary. Anyways, we'll see about what are these slowly. So this you remember. Okay. So let me tell you what and all are these gonna tell you, right? So this prefix is gonna talk about the branches. Right, branches in the sense if you have a methyl group branched, right? Hope you know what is a methyl group, CH3 group branched, right? Okay, so all the branches will be that is what is specified by prefix. Okay, now this root word, right? This root word talks about the number of carbon atoms, right? This root word, say you write, right? Meth, eth, prop, right? Prop, you have but, hex, pent, all these things, right? That is what is called as root word. Obviously, you know, it is going to talk about the number of carbon atoms. Meth means 1, eth means 2, prop means 3, but means 4. Okay. Now remember, it is going to talk about the number of carbon atoms in the main chain. More important, guys. It is actually going to talk about the number of carbon atoms in the in the main chain. So basically you're identifying the longest possible chain. That is what is called as main chain. Right? Okay, it talks about the number of carbon atoms in the main chain. Okay, right. Now last one, suffix, is going to talk about the functional group. Whether it's an alcohol or whether it's an alkane or an aldehyde or a ketone or an ester or an acid or whatever it is. Right? Now that is spoken by the suffix part. Okay, right? It talks about the functional group. Okay, so prefix talks about the branches, root word talks about the number of carbon atoms in the main chain, and suffix talks about the functional groups present. Okay, right? So this you remember, and then now we can go see the roots. Right? Any questions till now, guys? I think you must have now will be able to connect whatever you have learned little somewhere. Okay, so anyway, so move on. So now going back to the rules. That is the IUPAC rules for naming a compound, right? So the first rule is that you have to identify the longest possible chain. Okay, you have to identify the longest possible chain. Right now, this particular thing, if you do, guys, right, this thing you do, you got one thing sorted. The one thing which you got sorted among these three is the root word. If you do the first rule properly, right, if you do the first rule properly, you will get the root word straight away. So if you found 4 carbon atoms or 5 carbon atoms or whatever it is, you will know what will be the root word. Okay, but you have to be pretty careful in doing the root word. Okay, say for example, let me give you a compound. Say, okay, and guys, hope you remember there are different ways of representing the compound, right? So hope you know there are. I can draw the structures like this and all. Hope you know, right? This you know. Hmm? This way of representing organic compounds, do you know?
Yes, sir.
Yes.
Okay, anyways, if it's not, you're not confident, don't worry. We'll again take it up. Do not worry at all. Okay, fine. Let me do it normally itself then. Right. Fine. Say if I have God, what is happening? Okay, now tell me, guys. In this compound, this is a hydrocarbon that doesn't have any what to say, any functional group, right? Now tell me what will be the root word of this compound?
Hex, sir.
Hex, sir.
Hex. Okay, fine. We'll check how hex. So now if I take, there are so, see, remember, whenever you have hydrocarbons only present, right? Start with CH3, end with CH3. That can be any chain. But in that, you have to choose the longest possible chain, right? You can start with any CH3, end with any CH3. Okay, is that cool? Right. Fine. So we'll see how it happens. So if I start here, okay, this is 1, 2, 3, 4, 5. Right? I am getting 5 carbon atoms in the chain. Let me check any other way is possible. Okay. Say now I can take 1, 2, 3, 4, 5, 6. Now you're getting a 6 carbon atoms. Right, but there is another way of going. This is, I can even get 7. How? If I start from here, if I take this chain, see how much is there. 1, 2, 3, 4, 5, 6, 7 carbon atoms. That is the longest possible chain. Right, so you have to be very, 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 very careful. Right, just because you see that they are in the branch, right, it doesn't mean like that. It basically, I should have written this here and this here. That would have been a better way of writing, but still this is not a wrong way of writing. That's what I'm trying to tell you. Right, you see here, if you start with 1, 2, 3, 4, 5, 6, 7 carbon atoms are there. So for this it will be hept. Be very, very careful. Okay, start with CH3, end with CH3. But again, CH3 will work only if I have hydrocarbon. If you don't have, start with the functional group. I'll tell you how to do with functional group. Okay, so everybody understood how is it 7 and how the root word is hept?
Yes, sir.
Okay, so here it is 7 carbon atoms. Cool. So this is the first point. You have to identify the longest possible chain. Cool. Right. Next point. Second point regarding this is that you are going to number the carbon atoms right? Number the carbon atoms in the longest possible chain only. I'll write longest possible chain. LPC means longest possible chain, right? You have to number the carbon atoms in the longest possible chain, but not randomly. You cannot, you have 7 carbon atoms, but there is a way of doing it. Okay, how do you, where do you put 1? Where do you put 2? All, I mean, okay, if you put 1, obviously next one will be 2. But where to start, where to end is the question. Right, so now you're going to put numbers in the carbon atoms such a way that the more prioritized group, the high priority group, gets lowest possible number. Lowest number. This is the rule which you have to remember. Okay, you are going to number the carbon atoms, yes, and you're going to number the carbon atoms only in the longest possible chain. See, when I took this, right, now this and this I don't consider in the main chain. If I include that also, it will become oct. Actually, not oct. It will become dec. Right, but see, I am not numbering any the thing which are not in the main chain. I am doing it for the carbon atoms which are there only in the main chain. Okay, fine. And obviously now we'll tell you what do you mean by this higher priority groups. Okay, so for that you need to know the priority order for a different functional groups. If you have as branches, basically when I say priority groups, basically I'm talking about the branches. Okay, now we'll take an example. Like, say, okay, first of all, I'll give you the priority order, then we'll look into it. Okay, so the least priority goes to CH3 as a branch. CH3 will get the least priority. Okay, then any other thing, say C2H5. So bigger and bigger is the alkyl chain, the branch C2H5. See, remember when I say alkyl group, in general I can call all of them together as R. Right, it's a representation. Right, when I say R represents an alkyl group. Okay, so it can be CH3, it can be C2H5. So generally, when you're going to write a reaction, right? So generally, I will not mention it as C2H5 or CH3 because any hydrocarbon chain will work in the particular reaction. So for that reasons, I just use R. R in general represents an alkyl group. Okay, so basically R, the alkyl groups have the least priority. Again, among alkyl groups, among methyl, propyl, isopropyl, all these things, then CH3 has a less priority, C2H5 has more priority, propyl group will have higher priority. But in general, alkyl groups have the least priority. Is it okay? Right. Next comes X. Okay, when I say X talks about the halogen part. So again, in the halogen part, you have 4 halogens. That is your fluorine, chlorine, bromine, and iodine. Right now, in this case, which again you can see from here, more molecular mass, more priority, isn't it? So iodine will have the maximum priority, then bromine, then chlorine, and the least is fluorine. Okay, so R has the general lowest priority. Again, among alkyl groups, you have so many. Again, you learn the priority order. Then after that comes your X. X are the halogens. Again, you have 4 halogens, F, Cl, Br, and I. And this is the priority order among these 4. Okay, no doubts. Right. Next comes C triple bond C. Right, when you have a triple bond, obviously when you have a triple bond, you have to start with that carbon atom having triple bond. That has to get the lowest possible number. Okay, so anyways, so after that you have C double bond C. Okay, so you see double bond has more priority than triple bond, remember that. Okay, next, maybe right after that I have alcohols, OH, right? Then comes aldehydes or ketones, or I'll write first. Actually, aldehydes have more priority than ketones. So ketones comes first. Then comes your aldehydes. Aldehydes, I just write it as CHO. Okay, CHO is aldehydes, and the last priority goes to, I mean, the maximum priority has to go to acid, though the maximum of all. Okay, acids will come. Right, and one more thing, you have amines also, NH2 group, that will come after, that will come before OH. Okay, after C double bond C, NH2 amino groups. Okay, and when you ask, sir, what about the acid derivatives, esters, amides, all these things, they will all come before acids, after aldehydes, before acids here. Right, so all these things are what are called as acid derivatives. Okay, and there is a reason why they are called acid derivatives. I'll tell you why are they called like that. Okay, between your what is that, aldehydes and acids, you get your acid derivatives. Acid derivatives can be acid chlorides, amides, esters, all these things. We'll not worry much about it because you'll not be asked about the naming of those. But all the majority things are mentioned here, right? And it is a must. It's a must that you remember the priority order. If not, you will not be able to even answer simple questions in IUPAC naming. Okay, so this you remember the order. Right, fine. Now we'll take some examples, right? So So now if we have a compound, okay guys, I actually wanted to teach you this. So like this compound you saw here, right? CH3, basically this compound you saw here, isn't it? Right now, this compound can be easily represented another way, right? So what is the other way is what with the help of just lines, with the help of just lines, right? I'll be able to just represent this compound, and it's an easier way of doing it rather than every time writing CH2, CH3, CH3, all these things, right? Now there is an easier way of writing that the same compound, right? The same compound, I will be able to represent it like this, right? See how many carbon. Okay, let me take this as the main chain, right? This as my main chain, right? If I take it, so how many carbon atoms is 7 carbon atoms, right? So you can make 7 so in the lines, the joining points, the vertex, the edges represents one vertex represents 1 carbon atom. Okay, so now you should have 7 corners because there are 7 carbon atoms in the main chain. Okay, so how many? 1, 2, 3, 4, 5, 6. Oh god, 7, right? 7 carbon atoms. If you check each vertex, 1, 2, 3, 4, 5, 6, and 7 carbon atoms. Okay, right. Now you can see where are the methyl groups. Obviously, you have to account for this also, this methyl group and this methyl group also, right? So where will you account for it? You can see if you start numbering from either where, say you start numbering from here, 1, 2, 3, right? Third carbon atom has a methyl group, right? Again, 4, 5, fifth carbon atom again has a methyl group. The third carbon atom and fifth carbon atom has a methyl group. Correct. So if you start numbering from this side also, if you check 1, this is 1, this is 2, this is 3. Again, you see third carbon atom, fifth carbon atom, both has a methyl group. So in this case, this compound is a symmetrical compound. These are what are called as symmetrical compound. Either way you number, right? The branches is the where the branches are present is not changing, right? So these are what are called as symmetrical compounds. So what you have to understand is you have to put a methyl group in the third carbon atom, 1, 2, 3, you can see, and in the fifth carbon atom, so 4, 5, right? And you can just leave it just like that. Okay, so if I leave it just like that, by default, it means a methyl group here. CH3 is here, it means. If I don't mention anything also, right? If I don't mention anything also, right? If I don't mention anything also, it by default, it represents methyl group. Again, Me represents methyl group. You don't have to even write it. But if there's something else, say for example, in this case, if you had a OH, that time you have to represent it. If you just leave it, that means it's not understood. You have to put a OH and a OH, something like this. Is it okay?
So if we extend the line, that means it's a methyl group, sir.
Yes, if you just extend the line, if you just put a branch, and if you don't put anything on the branch, by default, it is methyl group. But if you want to mention anything else, if it's a C2H5 group or a Cl or anything other than CH3, you have to specify it there. But if it's CH3, you don't have to specify. By default, it is CH3. Okay?
Okay, sir, understood.
Right. Cool. So this is a very small way of representing. Very easy way, very easy also. Okay. But please be very careful in counting the number of carbon atoms. A lot of people do a mistake here. Right? Remember, this also is a vertex. I'm sorry, this also is a vertex. This also is a vertex. Each and every edge or vertex represents a carbon atom. Okay, please be very careful. Fine. What is the time? Okay, fine. So now we'll take an example. That's what we are trying to do, right? About the priorities, right? Say, if I give you a compound like this. Okay, I have a double bond here. Assume that there's an iodine at the last carbon atom. Okay, now tell me, where should I start numbering from? From the left or from the right? Okay, you can look at the priority order. Right now, I can look at the rule also. What is the rule? This rule says the highest priority should get the lowest number. Right, the highest priority should get the lowest number. Okay, now tell me, where should I start numbering from left or
Left to
right?
right, sir.
Exactly. Now you see there are two functional groups here. One is the double bond. Oops, right, one is the double bond and the other one is iodine. Now go here. You see X is here and you see the C double bond C is here. That means what? C double bond C has more priority than halogens. Correct, right? So definitely, if you start from this side, if you put 1, 2, 3, oh God. 3, 4, only in the fourth carbon atom you're having a double bond, right? But when you start from this side, 1, 2, 3, in second carbon atom itself, you are getting the highest priority. It's all about the highest priority. You really don't care about the lowest priority, right? So anyways, there are certain cases you will go for the second priority also, but I'll tell you when. Right, in this case you see that there are two functional groups. One is double bond, other one is iodine. So definitely looking at the priority order, double bond has more priority, so that has to get the lesser number when you number the carbon atoms, right? So you have to start from left to the right. That's how you must number this. Is it okay? Right, fine. So let me give you one more also. Let's say, sorry. Okay, now tell me from which side I should number. Yeah, from left or from the right. We'll talk about the name, what is the name later, but I'm just telling you how to number it first. Then we'll talk about it.
Sir, from left to right, sir.
Okay, we'll check. Now you see there are how many functional groups? 3 functional groups, or I would say 3 different branches, I can say, whatever, 3 different groups are there, right? One is double bond, one is the ethyl group, and the other one is when I don't put anything, that means it's methyl group. I told you, right? And I don't put anything, it's a methyl group. CH3 is here, right? Okay, now obviously first priority goes to
Double
bond, right? So both these double bond together should get the lowest possible number. So we'll see how it's done, right? So let me put the numbers. So let me put random. Let me check what's coming. So 1, 2, 3, 4, 5, 6. Right. So tell me where and all you see the double bonds. You see double bond in the second carbon atom. Again, you can see second and third, but again you have to take the lowest number. So second carbon atom and fourth carbon atom. If you go from left to right. Okay, now if you let me come from that side, say 1, 2, 3, 4, 5, 6. Again, where do you see the double bond? 2 and 4. So either way you go, this side also you're getting 2 and 4 double bond. That side also you're getting 2 and 4 only double bond. Now these are the cases where you have to look at the second priority. Right? Because however you go, the highest priority is having the same number. Right? So in these kind of cases, you are going to look at the other priorities. What is the next priority after double bond here in this problem? After the double bond, exactly, right? You can see next one is alkyl group. There's no other thing, right? So you can see next one is alkyl group only, and I told you when I compare CH3 and C2H5, C2H5 has more priority. Okay, right? So now I have to make sure that since my first priority is having same on both sides, my second priority now should get the least possible number, right? So the second priority here is my C2H5, right? So when I go from left to right, 1, 2, 3, 4, I'm getting 4 as the number, right? But when I go from right to left, 1, 2, 3, in the third carbon atom itself, I have a methyl group. So obviously, you have to go from right to left in this particular case. Understood, guys? Everybody understood? I'll repeat again. See, I have two double bonds. So either way you go, 2 and 4 and 2 and 4, you're getting left to right or right to left, right? So that is not going to help me. But you have other things also to look at. You have a methyl group, you have an ethyl group, right? So now I know out of these two, ethyl group has more priority. Ethyl group has more priority, right? So now we have to make sure that the ethyl group, you have to number the carbon atom in such a way that the ethyl group gets the least, least number, right? So let me check. So if you put the numbers from left to right, 1, 2, 3 is here, 4 is here. You're getting 4 as the for ethyl group, right? Let me check from that side. 1, 2, 3. This is the carbon atom which I'm talking about. And this carbon atom will come in 3 itself, right? So obviously now this is getting a least number, right? So that is the way you should number from right to left. Okay, everybody understood now?
Yes, sir. Understood.
I want everybody to give me a yes. Understood, everybody? Yes. Okay. 1. I have 7 people. 2 people have said me. 5 more. Yes. Did you understand? Okay. Good. Then 4 more. 3 more. Okay. Fine. Cool. So hope everybody understood. Right. Whatever. Right. Anyways. So this is how you're going to number it. Right. Fine. Now, what is the time, guys? 7:56. Huh? Fine, guys. I think I'll stop with this. Okay. Let me continue tomorrow because so many things I've learned, right? So we will actually get into naming properly. We didn't even get into like 5-10% of whatever the naming is. Okay. Fine. We will do it slowly, and I will make sure that any compound given to you, you are going to name it, right? But the only thing which I require from your side is your participation, right? So see, now also I asked 3 people. I think they have just logged in, and then I think they're sleeping. That's what they're doing, right? So if at all I want to take action for this, I can take action. Like I don't think they will even know this whatever I'm speaking, but still, right? But the interest, it should not be forced. It should be coming from you. Then only it will be fruitful, isn't it? So yeah, so more and more you participate, more and more you can ask me, sir, why this, why that? You can twist and turn me, you can squeeze me with all your questions. You are welcome to do that, right? You let me see. No, you ask one question and let me see, and like we'll keep it as a challenge. Okay, so from next class, right? You ask whatever you want, in the sense that whatever you're learning, like not like some you learn something in Google and come and ask me about chemistry. No, whatever you're learning in that particular day, right? If you ask a good question, I'm not able to answer for that. Let me give you a treat. But it should be a valid question. And you know me, right? I'm fair, right? If I'm not able to answer, I will tell you. I will not tell you any wrong answers. Okay. So like especially in organic, it will work. It will be very interesting if you're gonna do that. So why not this side? Why that? Why this came here? Why not here? So those kind of questions. Okay, so let me make it more interactive. We are just going to end up the syllabus. We have just 2 more chapters, and we are having fortunately 2 more amazing chapters. We'll make use of this. Okay, fine, guys. Thank you so much. We'll meet
I
again
have a
tomorrow.
doubt.
Yeah, Kana, tell me.
So the name of this compound is 3
Yeah.
ethyl 5-methyl dihexene.
No. Okay, fine. Let me complete this. Right. So whenever you have two double bonds, right, it has to end with diene. Okay. So fine. Let me tell you. So as you said, it's 3 ethyl. What is it? 5 methyl. Okay, bear with it. Right, 5 methyl, and then you have basically how many carbon atoms? 6 carbon atoms. So it's hex. Okay, and you have to mention where and all the double bonds present. Double bonds are present, are you seeing 2 and 4? So hex 2, 4 di. Right.
Okay, sir, understood.
Yeah, it's dying. Anyways, right? So, anyways, I'll tell you how and all this came. Don't worry. I'll tell you why this 2 and 4. Where should you use this? What are other ways of writing it? Do not worry. We'll go slowly. We are just now concentrating on how to number it. Okay. Right. Fine, guys. Thank you so much. We'll see you tomorrow.
Thank you, sir.